Good evening, everyone. Today we will discuss about the KOHLRAUSH law. Okay. So KOHLRAUSH law is also known as what? KOHLRAUSH law is also called as law of independent. KOHLRAUSH law is also known as law of independent migration of ions. So in this class, we will clearly understand what actually is KOHLRAUSH law. And so specially KOHLRAUSH law said about molar conductance of any electrolyte. Okay, mainly weak or strong, both of them. Especially weak electrolyte. He said about the molar conductance of weak electrolytes. So let us take an example. Okay, let us take an electrolyte like KCl. Okay, KCl is an electrolyte. Let us take an electrolyte like KCl. Lambda not KCl. In our previous class, we have already studied or we have already covered the molar conductance, specific conductance, equivalent conductance. There are definite definitions and unit also. You can follow all the videos. Okay. So he said that the molar conductance of KCl at infinite dilution will be 149.86. Okay, 149.86 ohm centimeter square mole inverse. This is the unit of molar conductance. Then from experiment also, lambda naught of NaCl will be 126.45. Same unit. By subtracting both of them, we will get what? We will get lambda naught m K plus minus of lambda naught m NaCl. And the value will be 23.41. Okay. Very simple. Unit will be same. Okay. Unit will be same. This is K plus and this is Na plus. Cl is common. So here common ion is Cl minus. Okay. Okay. Let me take some another example. Let me take KBr. KBr lambda naught m KBr lambda naught m NaBr. Okay. We have just replaced this anions Cl minus with Br minus. This is potassium chloride. This is potassium bromide. This is sodium chloride. This is sodium bromide. So what what actually we are here to do, we are going to do. Actually, we are going to replace these anions with Cl minus with Br minus. Okay. So here KCl, this is called potassium chloride and this is called as potassium bromide. Whereas this is called as sodium chloride, where this is called as sodium bromide. Okay. But the values are actually molar conductance of KBr is equal to 151.92, whereas molar conductance of NaBr is equal to 128.51. Okay. By subtracting both of them, we will get what? Lambda naught K minus of lambda naught M. Na will get what? We will get 23.41. If you observe both the difference, we'll get same difference of molar conductance. Are you all getting my point? What I tell you here? These two values of differences of molar conductances are actually same. But if you clearly observe here, negative ion is what? Br minus or bromide ion, here Cl minus. But anions, cations are same. Here Kna. Okay. But I just replaced Cl minus with Br minus. But there is no change in the value of difference. That means one point is clear. One point is clear. By changing anions, their molar conductance does not change. Clear? Yes or no? Does not change. Are you all getting my point? Very simple. Okay. So let's go forward. Okay. That means what? That means we can say that if I change the cations also, if I change the cations by changing the cations by replacing the cations with other ion by replacing cations, also there is no change in the molar conductance, in the molar conductance. Clear? Yes or no? Very simple. So here by observing, by doing this experiment, the Kohler cleared that every and each ion have individual molar or equivalent conductance. Okay, let me take some example like K plus Cl minus. Okay, K plus here KCl, here NaCl and here NaCl and this is KCl, this is KCl. Okay, so here individual conductance is lambda naught m. K plus is actually is 73.5, whereas lambda naught m Na plus is 50.1. Are you all getting my point? Yes or no? So all these like anions, we can take anions also. Lambda naught m Cl minus is equal to 76.3. Lambda naught m Br minus is equal to 78.1. So from the all these value we can clearly state that in case of both anions and cations, there is no dependency in their molar conductance. That means both anions and cations, they both does not depend upon each other in their molar conductances. That means by replacing both of them, we don't observe any change in their molar conductances. This theory is actually said by what? Kohler. So what is Kohler's law statement? So let me write here the statement of Kohler's law. Let me write the statement of Kohler's law. Okay. So what is the statement of Kohler's law? Let me write here. Statement. Okay, statement. Statement. What is statement? Statement is at infinite dilution. Infinite means heavy dilution. Vast amount of water is used. More amount of water is used. Very dilute solution. At infinite dilution. At infinite dilution, when dissociation is complete, dissociation is complete, each ion makes a definite contribution towards molar or equivalent conductance of the electrolyte. Clear? Of the electrolyte, irrespective the nature of other ion with which it is associated, and the value of equivalent or molar conductance at infinite dilution at infinite dilution for any electrolyte, very simple. Let me write first. Of an electrolyte is given by the sum of the contributions of the two ions, very simple. Okay, also, okay, this statement is very lengthy, so we can write a simple short statement. Okay, you can write also that statement. I'll write here. Okay, also Kohler's law states that it states that it states that limiting molar conductivity. What is limiting molar conductivity? When concentration is approximately zero, that means heavy amount of water is diluted or added, but that actually is mean infinite dilution. So when concentration is approximately zero, then that is called as limiting molar conductivity. Limiting molar conductivity of an electrolyte can be represented as the sum of the individual contributions of the anion and cation of the electrolyte. So what do you mean by this statement? Okay, you can clearly understand that what actually it means. It states that limiting molar conductivity of an electrolyte can be represented as the sum of the molar contribution individual contribution of the anions and cations of the electrolyte. Okay. First, let me clearly tell you about this lengthy statement. At infinite dilution means heavy amount of water when added in the solution. Okay, the electrolytes, when dissociation is complete, strong electrolyte also strong in presence of water, strong electrolyte always dissociated completely. That means the degree of dissociation is 1. That means it is 100% dissociated, not partially. But weak electrolyte, in case of weak electrolyte, it also at infinite dilution is 99% but dissociated. Each ion makes a definite contribution. That means in any electrolyte, every ion must, like in KCl, K plus must contribute its electrolyte conductance, that is 73.5 ohm centimeter square mole inverse. Like in NaCl, Na plus represents its own molar content, that is 50.1. Like Cl minus represents its own molar content, that is 76.3 ohm inverse centimeter square. Ohm centimeter square and ohm inverse centimeter square and mole inverse. Okay, its unit all know that. Okay, ohm centimeter square mole inverse. Okay, so I think it is clear to all of you what actually it means. Okay, towards the molar conductance of electrolyte irrespective of the nature of other ion. That means there is no dependency of any anions or cations. That means here cation does not depend upon the conductances of anion, whereas anion also does not depend upon the molar contents of cations. Okay, they both does not depend upon each other. They have individual conductances. Okay, which can be calculated by adding them both. So let me write here according to the statement. If example lambda not m cs3 COOH. This is a weak electrolyte. So what is the value of this lambda not m? This is we can read as molar conductance of acetic acid at infinite dilution. So we can write that lambda not m cs3 COO minus plus lambda not m H plus. We can write that, okay? But it is very simple. But let me take some another example. Let me write here lambda not m CSCl2. It is also a salt, so I can write that it's an acid. Okay, it is a salt. Lambda not m Ca2 plus, but here 2Cl minus is actually present. That's why I can write that here 2 lambda not m Cl minus. Like that, lambda not m Al2SO4 whole 3. Okay, how can I write this salt? This salt and by as you clearly see here, 2 aluminum ions are actually present, 3 sulfate ions. That means we have to multiply it to 2 lambda not m Al3 plus 3 lambda not m SO4 2 minus. So as you clearly see, it is very simple, but here some coefficients are actually used. That means if I write here lambda not m A of x and B of y, one means x number of A molecules and y number of B molecules are present. That means x into lambda not m, that means x into lambda not m A plus is used, whereas y into lambda not m B minus is used. This is the general formula for KOHLRAUSH law. I hope everyone clearly understand what I tell you here. Okay, so I think it is clear to all of you. The main important point is here we can say the total molar conductance of any electrolyte is the contributions of its molar conductance of its ions. That means cations and anions. You can say any acid, you can take any acid, you can take any salt. Okay, you can take every any electrolyte, acid, base, salt. You can take everything. Okay, everything means only electrolyte which can. What do you mean by electrolyte? Electrolyte means any substance which when dissociates give to give what? Both cations and anions. Okay, I think it is clear to all of you. Okay, so now let me write a problem. Before that, we have to clearly understand what actually its application. So it's there are different applications actually used. First application, its application. Now we have to read about its application. Application of KOHLRAUSH law. How can we apply KOHLRAUSH law? KOHLRAUSH law. What is KOHLRAUSH law? Mainly we have clearly understood what actually KOHLRAUSH law is. Now we are going to understand what are the applications of KOHLRAUSH law. So KOHLRAUSH law, first of all, to determine the what? To determine the molar contents of weak electrolyte. To determine the molar conductance of weak electrolyte. Okay, for weak electrolyte this KOHLRAUSH law can be used. Okay, here here I write an example here. This is an example of weak electrolyte. Okay, so by using its if in a question it is given that the acetate ion molar contents is this, H plus molar contents is this, so we can add both of them and we'll get what? Molar conductance of respective acid. Okay, very simple. Now come to question number application number 2. What is application number 2? Application number 2 is calculation of what? Calculation of a degree of dissociation. Okay, application number 2 is very important. Calculation of degree of dissociation. Okay, Okay, we'll do a problem in next class. Okay, so application number 2 is to calculation of application number 2 is calculation of calculation of dissociation constant, degree of dissociation, sorry, calculation of degree of dissociation, degree of dissociation, calculation of degree of dissociation of a weak electrolyte. Okay, derivation of a weak electrolyte, weak electrolyte, clear? Calculation of degradation of a weak electrolyte. So first of all, let me write an equation for weak electrolyte, that is CH3COOH. When dissociates, it gives CH3COO minus and H plus. Okay. Okay, so CH3COH minus, its concentration is what? CH3COH minus have, it has, let its concentration initially its concentration is, let's see, C means it initially reaction does not start. That means only C is present, only CH3COH is present. There is no dissociation. That means there is no concentration. But finally, after some time, let C alpha number of molecules will be dissociated. Okay, what happens then? Then it will get reduced to C minus C of alpha. That it means what? If 3 number of molecules are present, 2 number of molecule will be dissociated. That means 3 minus 2, that is equal to 1. 2 number of molecule dissociated, that means 3 minus 2 is equal to 1. So these are the molecule which are dissociated. These are molecule which are remaining in the solution. Okay, which are not dissociated. I hope you clearly getting my point. You are clearly getting my point. So what happens here? What is case C then? Case C means equilibrium constant or dissociation constant. We can write Ka also. Okay, what is dissociation constant? CH3COO minus of H plus whole divided by CH3COOH. Very simple. Okay. Clear? Are you all getting my point? So what happens to case C? This is degree of dissociation, weak electrolyte. Okay, degree of dissociation means what? Alpha is called as degree of dissociation. So what is alpha? How can you calculate alpha? Alpha can be calculated by lambda m by lambda naught m. What is lambda m? Lambda m is molar conductance of electrolyte at any concentration. At any C, you can write C here. This is lambda molar conductance of electrolyte at infinite dilution. Okay. Okay, by putting this formula, we can easily calculate degree of dissociation. Okay, but by using degree of dissociation, we can also calculate Ka value. What is Ka? This is called as dissociation constant. This is called as dissociation constant. Okay, so by putting all these value, we can easily get the values. We can easily get a formula or the value of Ka. CH3CO minus, as you clearly see, CH3 in CH3CO minus place, C alpha is present. That means it is C alpha. Whereas H plus is also C alpha. Then my CH3COH is C minus C alpha. C minus C alpha means 1 minus alpha. We can take common C. So C here will be omitted. Then what happens? C alpha square C alpha square by 1 minus alpha. So we will get here what? Ka is equal to like this. So I hope it is clear to all of you. Okay, by putting the alpha value also, this value we can put here and get a value which is clearly mentioned in NCERT. Okay, I hope it is clear to all of you what actually is KOHLRAUSH law and what is its limitation. If you want any problem that you expect me to do in this video, then you can comment on this YouTube channel. Okay, then I will do some problems about KOHLRAUSH law, Nernst equation. We can do different kinds of problem. Okay, both CHSE, cbse. Okay, the 52% of my viewers are actually not following me right now. So everyone kindly watch, like, share, subscribe and follow me. Okay, thank you. Thank you everyone.